Okay, so today we're going to start Chapter 8. Now, Chapter 8 and 9 are completely different concepts than 6 and 7. So 6 and 7 were really abstract. I mean, there's fractions and, right, not really a lot of visual stuff to kind of go along with that. Chapter 8 starts kind of the idea behind linear functions. So we're going to start graphing, we're going to start finding slope and things like that, and I really think you guys will enjoy this. I hope so anyway. But that being said, we are going to start graphing starting on Thursday. So you don't necessarily need an entire sheet of graph paper for yourself, but between 4 or 5 people, that would probably be enough graph paper to go around. So maybe find somebody in this class or in another class that you guys can split some graph paper, or I guess you can buy a whole stack of it for yourself if you want. But starting Thursday, you guys will need graph paper, especially into next week, okay? But today, we're going to start Chapter 8. And Chapter 8 is titled Introduction to Functions. And today, we're going to be in 8.1. And 8.1 talks about equations in 2 variables. Which is a new idea as far as kind of in comparison to kind of what we've done this year. We have only talked about equations that have 1 variable so far. So let's look at kind of the examples of those. Let's look at some 1 variable equations. This is what we're used to seeing, 1 variable equations. Okay, these are equations that look like 2x minus 3 equals 7, right? Just an x, 1 variable equations. Or 1 minus y equals 9. Once again, it's a different variable, but it's still 1 variable equation. Or even whenever we went to Chapter 5, maybe x squared plus 5x plus 4 equals 0. So I have an x squared, it's a little more complicated, but it's still just an x, right? 1 variable equation. Okay, well let's talk about some things we know about these types of equations. If I look at 2x minus 3 equals 7, I could solve that, right? Add 3 to both sides, divide by 2, x equals 5. Okay, x equals a number. For the second one, subtract 1, and then multiply by -1, and you get -8. Y equals -8. You get a number, right? For the last one, you have to do a little bit of work. We'd have to solve this one by factoring. So look, factors of 4 that add to 5. You come up with 4 and 1. You'd have x plus 4, x plus 1. Inside each factor equals 0. It's a lot more complicated. And you end up with 2 answers. You would end up with -4 and -1. But they're still numbers, right? X equals a number, okay? So when we're talking about 1 variable equations, the solutions to these equations are numbers. Which you're probably thinking, well, duh, what else could it be? We're talking about math here. Of course it's going to be a number. But what the difference is whenever we look at these 2 variable equations, it's going to be just slightly different. So 2 variable equations, on the other hand, they're going to look like 4x plus 3y equals 10. So notice I have an x and a y, 2 variables. Or xy equals 6. Or even if we want to get more complicated, x squared plus y squared equals 4. Okay, more complicated, but still 2 variables. Okay? If I'm talking about the solutions to these equations, if I look at this first one and I wanted to solve for x, okay, and we've kind of done this before, but if I wanted to solve for x and find out what x equals, subtract 3y and divide by 4, would you get a number? No, right? You wouldn't get 5 like we did here, or -8. It would be an expression. It would be -3y over 4. Or, -3y over 10 minus 3y over 4. It wouldn't be a number, it'd be an expression. Okay, so I can't really solve, I guess, per se, if you're looking for a number. And same thing here. If I tried to solve for x by dividing by y, I'd get x equals 6 over y, which is not a number, it's an expression. Okay, so looking at these equations, I can't give you 4x plus 2 equals 10 and say solve. Because you can't, okay? Solve for what? You don't know. Now, if I give you a value for x, you could plug it in and then solve for y. And if you do that, let's say I tell you to plug in 1 for x. And you plug in a 1 and you have 4 times 1 plus 3y. You end up solving for y and you end up with 2. Okay? And when this happens, you actually kind of have two answers. You have a value for x and you have a value for y. So what that tells me is the solutions of these equations, since they have two solutions, these are called ordered pairs. These solutions are an x comma y. So one variable equations, it was just x equals 5. But this one would be 1 comma 2, negative 3 comma 4. Okay, two answers. An x maps to a y. Okay? Making sense, kind of? Yes? Okay, we're going to have two things we're going to do today. First thing that we want to do today is we want to just decide whether an ordered pair is a solution to an equation. So we're going to state whether each ordered pair is a solution. And we've kind of done this before, so kind of on a side note, don't necessarily have to write this down. If I give you the equation 3x plus 4 equals 10, equals 10, and I give you the value x equals 2, and I wanted you to tell me, is this a solution to the equation? What would you do? You'd plug it in, right? You would plug 2 in for x. If it gives you a true statement, okay, yeah, it's a solution. If it gives you a false statement, it's not a solution. So we're going to do the same thing today, except if I have an x comma y, I'm going to have to plug in a number for x, and I'm going to have to plug in a number for y. But the idea is the same. Okay, so number 1, if I have the equation 7x minus 2y equals 0, and I'm actually going to give you two ordered pairs that we're going to try. The first one, I want to know if 2 comma 7 is a solution, and then after we do that one, we're going to check if 3 comma 4 is a solution. Okay, so if I want to know if 2 comma 7 is a solution, I'm supposed to plug this in here, okay? But I don't even see an x and a y. It doesn't tell me x equals 4. I know 2 comma 7. How do I know what my value for x is? Why do you say 2?
Because ordered pairs are always x and y.
Very good. Ordered pairs are x comma y. Or they go in alphabetical order. If you're talking about a's and b's, it would be a comma b. Okay? So x comma y. So x is 2, y is 7. So I'm going to plug 2 in for x, and I'm going to plug 7 in for y. And I'm checking, is this going to give me a true statement? So 7 times 2 gives me 14. 2 times 7 gives me 14. Is this going to work? Yeah, this works. If you get a true statement, that means yes. 2 comma 7 is a solution to this equation. Okay, then we do the same thing with 3 comma 4. These are completely separate. They just happen to be the same ordered pair on the equation. So we're going to do the same thing, except this time I'm going to plug 3 in for x, and I'm going to plug 4 in for y. So if I have 7 times 3 minus 2 times 4, I'm checking, will that give me 0? Okay, well 7 times 3 gives me 21, 2 times 4 gives me 8. Is that going to equal 0? No. 13 equals 0, that's not true. So that would tell me no. 3 comma 4 is not a solution. Okay, make sense? Let's plug in numbers in, we've kind of done that before. Now on another side note here, which is kind of important to know this, what you're actually finding, 7x minus 2y equals 0 is an equation of a line. Okay, so if I somehow graph this line, and it looks like this, it probably wouldn't. What it means for these points to be a solution, it means that this point is on this line. It means that this line crosses through 2 comma 7. So if I plotted 2 comma 7, which it obviously doesn't work out, but it should fall on the line. But then if I plot 3 comma 4, whenever I plot it, it would not fall on the line, okay? Does that make sense? So any point on this line, if I plugged it into this equation, it would give me a true statement. Any number, any ordered pair not on the line would give me a false statement. Does that make sense? Okay, you don't have to actually do that today, but just kind of knowing the process behind it. Okay, questions on number 1? Okay, let's try one more of those. Number 2. X squared minus 3y squared equals 15. X squared minus 3y squared equals 15. Okay, so I have my equation, and we're going to check 2 points. We'll do the first one together. I'll have you try the second one on your own. I want to check if 4, negative 1 is a solution, and then we're going to check if negative 4, 1 is a solution. Okay, now for this one, you have to be really careful because not only do I have negative numbers, but I also have exponents. So be very careful when you're plugging in your numbers. It's a good idea to use parentheses. So for that first point, if I plug 4 in for x and negative 1 in for y, I want to know, will that give me 15? Okay, well this time I have to use some order of operations. So order of operations tells me to do what first? Exponents. Says parentheses, there's no parentheses. So next we're going to jump to exponents. So I have 2 sets of exponents that I can evaluate at the same time. So I have 4 squared, which gives me 16. Negative 1 squared gives me what? 1. And I want to know, will that give me 15? What do you think? Is it going to work? Doesn't look like it, because 16 minus 3 gives me 13, and 13 does not equal 15, so no. 4, negative 1 is not a solution. I want you guys to take a second, try negative 4, 1, see what you come up with. Okay, so hopefully we got no, right? You actually end up with the same thing, right? 13 equals 15, which is not true. So negative 4, 1 is also not a solution. Okay, this is what the first part of your homework is going to look like tonight. So solve them both separately. You'll have 2 answers for each one, and they're completely separate from each other. You're just plugging them into the same equation. So this one has no bearing on the other one. Okay, questions on the first 2 examples? No? Okay, you have one other thing that you'll do in your homework tonight. Now, I told you that you can't necessarily solve these equations, right? I can't just give you an equation and tell you to solve it. But what we can do, the directions will say solve each equation. And it's going to give you some criteria. And the criteria is going to say if x and y are whole numbers, which may not seem like much, but it actually means a lot, and it cuts down my work a lot, because x and y can only be whole numbers. So whenever I end up putting my answer as an x, y, I should have a whole number, another whole number. So we probably need to decide what a whole number is. What is a whole number? No fractions and decimals. Okay, so I can't have 1/2. I can't have 13.2. Is that the only criteria? Cannot be negative. Whole numbers are always positive, okay? Well, you got one number that kind of goes back and forth. What about 0? 0 a whole number? 0 is a whole number. It's not a natural number. 0 is a whole number, okay? So we're going to solve for x and y, but x and y both have to be whole numbers. So if we find out that x is a fraction, not going to work. Or if we find out that y is a negative number, it's not going to be a solution, a whole number solution. Okay? So we have to do a couple of things before we can even solve this. So let's try 3x plus 4y equals 12. 3x plus 4y equals 12. Okay, so if x and y can only be whole numbers, one thing you could do is we could just start plugging whole numbers in for x and solve for y, okay? We could plug 0 in for x and then solve for y, and it wouldn't be too bad, right? But we'd have to solve every time, right? Wouldn't it be nice if we could just plug it in and simplify and we didn't have to solve? Yes? Yes? Remember back in chapter 4, whenever we did the transforming formulas and you guys hated it and you're like, when are we ever going to use this in real life? It's not really real life, but it's later on in math class. We're going to use that, okay? We're going to solve for a variable. And now, kind of looking ahead, which isn't going to make sense to you, it will later on down the road, maybe later on this week, we're going to either have to solve for x or we're going to have to solve for y. If it's convenient, try to solve for y. Once again, it's not going to make sense today, and you're like, well, I want to solve for x. I'm going to solve for x. And then that's fine. You should get the same answer. But looking later on down the road, let's try to solve for y if possible. If it's really convenient to solve for x, then you can go ahead and solve for x. But looking to the future, let's try to solve for y. So in other words, instead of 3x plus 4y equals 12, I want this to say y equals something. Okay? So I want y all by itself. What would I have to get rid of first?
You would have to subtract 3x from both sides.
Very good. We're going to subtract 3x from both sides. Okay, and I can't combine the 12 minus 3x, so it's just going to stay 12 minus 3x. And then how would you get rid of that 4? Divide by 4. Okay, now on the right-hand side, you could leave your answer like that. Once again, not necessarily wrong, but if I can simplify this at all, that would be kind of nice. Do you guys remember the butterfly rule? Where you do divide and divide, right? If you can do that, that's usually helpful. So now I have y equals 12 divided by 4 gives me 3. And then it's just going to have to stay 3x over 4. Okay, so for your homework tonight, if you're asked to solve an equation for whole numbers, solve for one variable. If you can solve for y, that's great. Okay, so now we have y equals. And this is nice because now whenever I plug numbers in for x, notice that I don't have to solve for y. I just have to simplify. You guys see the difference? It's a little more convenient now. Okay, so what we're going to do is we're going to draw a table. And we're going to do just that. We're going to plug values in for x. And we're going to get some values out for y. So this is kind of like your function machines that you did way back in the day. You know, you plug numbers in and then it spits another number out. Okay? We are going to plug possible numbers in for x, and we're going to see what y would get out. But remember, we have some criteria. X and y have to be whole numbers. Okay, so if I'm looking for a starting point, maybe I want to find what's the smallest value x could be. 0, right? That's the smallest whole number. So the first place we're going to start is we're going to plug 0 in for x. So y equals 3 minus 3 times 0 over 4. And what I'm looking for, I want to know what y would equal. So if I simplify this, 3 times 0 gives me 0. 0 over 4 gives me 0. 3 minus 0 gives me 3. So if x is 0, y would be 3. Are both of those whole numbers? Yeah, so this whole number solution would be 0, 3. Okay, then we're going to do the same thing. And we're just going to keep working our way up. Okay, what's the next largest number that x could be? Well, let's try to plug in a 1. So y equals 3 minus 3 times 1 over 4. Okay, now you guys are probably like, oh my gosh, you're going to make us do a whole bunch of fractions? No, I am not, I promise you. All we're looking for is if it's going to give me a whole number solution. So yes, x is a whole number, but when I plug 1 in for x, is this going to give me a whole number? No, it's going to give me a fraction. So once you decide it's going to give you a fraction, you don't even have to solve it anymore. All you have to do is just say, nope, that's not going to give me a whole number, so I'm done solving from there. If it gives you a whole number, you do need to finish solving it. But if it doesn't, you can just stop right there. So let's keep working up. Let's plug in a 2. So y equals 3 minus 3 times 2 over 4. So you're going to kind of start looking at the fraction. 3 times 2 over 4. Is that going to give you a fraction or is it going to give you an integer? It's going to stay as a fraction, right? So if it's going to stay as a fraction, 3 minus a fraction is going to give me a fraction, which is not a whole number, so we're just going to say no. And we plug in 3. Y equals 3 minus 3 times 3 over 4. What do you think? Will that one work? Nope, doesn't look like it because I'm going to get 9 over 4, which isn't going to work. Okay, well, let's try to plug in a 4. So y equals 3 minus 3 times 4 over 4. What do you think? Will that one work? Yeah, that one works because 3 times 4 gives me 12. And 12 divided by 4 gives me 3. And 3 minus 3 gives me 0. So 4 and 0, both whole numbers? Yeah? Okay, so 4 comma 0 is also solution. So far, I have 2 answers. We've done all of this work and I got 2 answers. So this stinks if I'm going to make you do this for all of your homework, right? You guys are totally pumped? Yeah? Okay, well, I took you through this whole process. That way you guys can appreciate what I'm getting ready to show you. What I'm looking for is I'm looking for the numbers that are going to give me not a fraction, right? That's kind of what you're looking out for. So looking at the numbers that I could possibly plug in for x, which numbers or what kind of numbers would end up giving you not a fraction? Rachel? Multiples of 4, right? Because the multiples of 4 will cancel that out. You guys see that? Okay, so really, I didn't need to plug in 1, 2, and 3. I only needed to plug in 4, right? Because it's a multiple of 4, okay? So, do I need to plug in 5? No, because that's going to give me a fraction. What about 6? 7? 8? Okay, need to plug in 8. So, if I plug in 8, I get y equals 3 minus 3 times 8 over 4. 3 times 8 gives me 24. 24 over 4 gives me 6. And 3 minus 6 gives me negative 3. What's wrong with that answer?
Negative.
Okay, it's a negative. So is that a whole number solution? No. Okay, well, what happens if you think I keep plugging in numbers larger than 8? They're going to keep getting more negatives. So once you see that you're getting negative solutions, then you're done plugging numbers in. Does that answer your question? Okay. So you'll know, because like I said, once you start getting in negative numbers, you don't have to keep plugging them in. Okay? Or somebody in the last class said, kind of once you hit 0, you can stop. Okay? You might plug in one more just to be safe. But the one number, definitely start with 0, because 0 a lot of the times will work. Sometimes it won't, but most of the time it does. Okay? Questions on the first one? Yes.
So what would be our answer?
0, 3 and 4, 0. Those would be your 2 answers. Okay? All right, let's try one more of those. If this will cooperate with me. Okay, you guys may just have to listen to copy it down until it catches up. X, Y plus X equals 9. X, Y plus X equals 9. Okay, so think back to our last problem. I want to solve if X and Y are whole numbers. What did we do first? What did we do first in the last problem? Isolate a variable. So I said that if we can isolate the y, let's do that. But if x is really easy to isolate, then go ahead and solve for x. But if I look at this one, notice how I have an x here and an x here, and I can't combine them. It would be kind of tricky, actually, to solve for x. So we really don't want to solve for x. It's going to be much easier to solve for y. So if I want, instead of this saying xy plus x equals 9, I want this to say y equals, what would you have to get rid of first? Right, the plus x. So we're going to subtract x from both sides. So I have xy equals 9 minus x. Okay, and then how would you get rid of the x? Okay, divide both sides by x. And then once again, to simplify, go ahead and use the butterfly rule. So I should end up with y equals 9 over x, which can't really be simplified at all, but x over x gives me just 1. Okay, so once you solve your equation for a variable, then we're ready to start plugging values in. So where should I start? 0. Let's try to plug 0 in for x and see what happens. So y equals 9 over 0 minus 1. What in the world? 9 over 0? What's wrong with that? You can't have a 0 in the denominator. It's undefined. So is that a whole number solution? No, it's not any kind of solution. So all we have to say is no. You don't have to yell and scream and say undefined. You just have to say no. Not a whole number solution. Okay, so now we've kind of figured out that I don't necessarily have to plug every single number in. Maybe we don't have to write every single one down unless we think that it might give me an actual solution. So the next logical number to plug in would be 1. If I plug in 1 for x, is it going to give me a whole number? Or an integer? Yeah, okay. Well, let's try to plug in 1 and just make sure it gives me a whole number solution. So y equals 9 over 1 minus 1. 9 over 1 gives me 9. 9 minus 1 gives me 8. So is that a whole number solution? Yeah, 1, comma, 8. Okay? I'll give up on it. Okay, now once again, if we're going to keep moving on, try to plug in 2. Maybe we don't actually write it down, but let's just kind of look. If I plug in a 2 here, is it going to give me a fraction or an integer? Fraction, which isn't going to work. So we're not going to even worry about plugging in 2. What if I try to plug in a 3? Will 3 work? Yeah, so let's plug in 3 for x and see what we get. So y equals 9 over 3 minus 1. 9 over 3 gives me 3, and 3 minus 1 gives me 2. Whole number solution? Yes, you guys are just going to have to use your imagination because I know you can't see it. Sorry. It'll catch up as soon as I start yelling at it. So, okay, so far we have 2 solutions, 1, comma 8, 3, comma 2. Let's keep working. If I try to plug in a 4, is it going to work? No. 5? 6? No. It'll simplify, but it still won't get rid of the denominator. So no 6. What about 7? 8? 9? 9 will work, won't it? 9 will work. So if we plug in a 9, y equals 9 over 9 minus 1. And what is 9 over 9? Just 1, right? Okay, and 1 minus 1 gives me 0. Whole number solution? Yeah, so we have 9, comma 0. Okay? All right, so now if we keep going, if I try to plug in a 10, will that work? 11? What about any number bigger than 9? No, you know, if I have a 9 in the numerator, if I have any number bigger than 9, it's going to end up being a fraction, right? So no number bigger than 9 will work because that will always be a fraction. So once you kind of recognize that, then you know that you can stop. Or, kind of like what I said before, if you end up at 0, kind of a good indication that you're almost finished. Okay, questions? So this one you would have 3 answers, 1, comma 8, 3, comma 2, and 9, comma 0. Okay?